Hello everybody, so today we're going to be talking about energy, work and power and discussing a few questions to um, to learn more. So the first question is, state the principle of conservation of energy. So the principle of energy is, or conservation of energy, is that energy cannot be destroyed or created, it is only transferred. So energy cannot be created or destroyed. Our second question, Fig 2.1 shows the energy flow diagram for a car powered by a petrol engine. Using the information from in Fig 2.1, calculate the percentage of energy transferred from the chemical store to the kinetic store. So here we can see that 70% goes into this store and 100% is inputted. So 100% minus 70% is equal to 30%, meaning the kinetic energy store is 30%. Fig 2.2 shows the energy flow diagram for an electric car. The electric car is driven by an electric motor which is powered by a battery. Using the information in Fig 2.1 and Fig 2.2, state which car is more efficient. Give a reason for your answer. So here we can see that there's more percentage going into the kinetic energy store, the useful output, not the wasted output. While in the petrol engine, more is going into the wasted output. So the answer is electric car because it is more efficient. The reason is because it has less wasted energy. A student holds a pile of books. The mass of the books is 3.2. Calculate the weight of the books. So the weight formula is mg, or mass into gravity. And gravity is always 9.8, and here the mass is 3.2. So 3.2 multiplied by 9.8 is equal to 9.8 into 3.2 is equal to 31.3, or just 31 newtons. The student carries the books from the bottom to the top of the stairs shown in Fig 4.1. The vertical height of the stairs is 4.5 meters. Show that the work done on the books when they are carried to the top of the stairs is approximately 140 joules. So formula is for work done is force multiplied by distance, and here the force is 31 newtons. So 31 newtons multiplied by the distance, which is 4.5 meters. The answer is 141 approximately, or it's 139.5, so it's approximately 140. Determine the gravitational potential energy gained by the books. Give a reason for your answer. Gravitational potential energy is equal to, gravitational potential energy in this case is equal to the work done, is equal to the gain in gravitational potential energy, and the amount of work done gained is 31 joules. So the answer here is also 31 is 140 joules. I mean that the work done is approximately 140 joules, so the gravitational potential energy is also 140 joules. And the reason is because work done is equal to gain in GPE, or gravitational potential energy. Fig 5.1 shows a tidal turbine. A tidal turbine generates electricity from the energy stored in tides. State two advantages of using the energy stored in tides for generating electricity compared with using a coal-fired power station. Ignore building and other costs. So one is it's renewable, and the second one is that it is no CO2, no carbon dioxide is emitted, making no greenhouse gases. State 2 disadvantages of using the energy stored in tides for generating electricity compared with a coal-fired power station. Ignore building and other costs. So one is that it is not always reliable. It's not reliable. It's not reliable, and it's difficult to maintain because it's in the ocean, so it's difficult to maintain. Energy is distributed from wind turbines to homes and industries. Statement A and F describe the main stages in the transfer of energy from the sun to electrical energy in the wind turbine energy. The statements A to F are not in order. Complete the flow chart to describe how a wind turbine uses energy from the sun to generate electrical energy. Insert the missing letters in the empty boxes. So firstly, what happens in the first process? It is from the sun. The sun heats the atmosphere. So over here, the energy is the C. So C into D, which is uneven heating. And then air moves from low pressure. Then the next one. So these three are already there. Now we have to add the rest 3. So the fourth one is F, because the moving air turns the turbine blades after the air is moving, it turns the turbine blades. So F, and then after F, the turbine blades turn a generator, and then the generator generates electrical energy. State 2 disadvantages apart from cost of using wind turbines to produce electrical energy for homes and industry. One is that energy output is not that large. It is not that large. It is small. We need a lot of them to power something compared to the fossil fuels. And the second one is that it is depends on weather. So thank you everybody. That's it for today.